Hello one and all, and welcome to our today's webinar. My name is Andrew Pasika and I am software engineer at Kaa IoT, and I will be your speaker today. I must say that this new release was quite a milestone for our team, and so we are really excited to share it with you today. We added some crucial features to enable enterprise IoT use cases and ensure end-to-end IoT experience for Kaa users. So if some of you are new to Kaa, it is a perfect time to enjoy this best Kaa ever. One more thing before we begin, if you have any specific question you would like us to answer, please spot them in the questions tab in the webinar sidebar, and we will get back to them at the end of the session. First, let's briefly look at how the Kaa IoT platform is built and what features it offers. These features you will be having with any flavor of Kaa, whether it is Kaa Cloud, Kaa IoT hosted instance or self-hosted Kaa. You can learn more about different Kaa options on our website and also sign up for free trial or Kaa Cloud account. All the features in Kaa are implemented with portable microservices, and Kaa as a whole is based on flexible microservice architecture. This means that you can separately customize each Kaa feature, add new ones, or replace any existing ones with some third-party tools. Out of the box, Kaa provides all IoT features that you may need for a typical IoT application, from data collection and device management to IoT dashboards and analytics. You can also take advantage of open APIs to integrate the Kaa features to your own modules and applications. Let me quickly talk about a few more advantages of the Kaa IoT platform, which may help you better assess its potential for your specific case. As I already mentioned, Kaa's modular architecture allows you to customize the set of features for your different solutions, applications, and even application versions. Moreover, on the user interface side, you can create a custom analytics dashboard and even change the look and feel to match your brand's colors. Kaa uses popular open IoT protocols based on MQTT and HTTP, while application-level protocols of Kaa by default use widespread JSON encoding available in all programming languages. You can white label the Kaa platform to build your own IoT solution under your own brand. There is also an embedded license available to enable you to distribute Kaa features to your own customers. A few more on the technical side. Kaa supports any type of deployment, public, private, or hybrid cloud. You can access it in the PaaS format, which we call the Kaa Cloud, host deploy and host separate Kaa installation for you, or install Kaa in a data center of your own choosing. Kaa also offers a variety of enterprise-grade capabilities, such as elastic scalability, high availability, self-healing container orchestration, and multi-tenancy, which allows you to run multiple organizations on a single Kaa instance. Speaking of the progress we have made with the Kaa for the past few months, let me introduce to our latest Kaa release 1.2. If you have been actively using Kaa for this period, you may have noticed that we were adding these new features as they were ready. In summary, our goal was to ensure that Kaa meets full-scale requirements of enterprise IoT users. That is why adding advanced multi-tenancy with full data isolation for each tenant was one of our top priorities. We also strengthened the platform security by adding flexible credentials management for connected devices. Then we added an HTTP transport to be used in addition to popular MQTT. Another useful feature is the ability to upload binary data such as multimedia from your devices to the platform, for example, uploading video from security cameras. What is more, we added analytics and alerts functionality in Kaa by seamlessly integrating it with the popular OpenDistro for Elasticsearch solution. It gives users vast powers of configuring analytics dashboard and setting up rule-based alerts. So it was the perfect match for our platform. There is also Endpoint configuration schema management, which allows IoT developers or admins to set up data formats and fields that regular users will be working with. And finally, a convenient feature in regard to enriching the collected device telemetry with various metadata attributes for better analysis and visual representation. Now let's look into each of these features, and I will also demonstrate how they actually work in Kaa. Kaa 1.2 implements an advanced multi-tenancy so that every platform tenant is isolated in a dedicated authentication and authorization key cloak realm. Thus, each tenant has a fully isolated space and can manage their own users, permissions, applications, their versions, endpoints, etc. Tenants are also able to configure their own external identity providers, for example, corporate LDAP, Active Directory, various OAuth or SAML providers. For fast and simpler creation of tenants, admins can also create reusable templates. Now let's see how it looks in Kaa. The first notable thing that you have with adding multi-tenancy into the Kaa platform is that now you should specify tenant ID or tenant owner's email during the login into the system. Here you have two options. You can log in as a tenant owner or as a regular user. Let's select the first option. My tenant has its own set of devices, applications, credentials, filters, etc. that are fully isolated from all other tenants. Another interesting thing is that you can click on User Management tab and you will be redirected to Key Cloak realm with all resources that belong to your tenant. So here you can manage users, you can add new users, you can view them, and you can manage their permissions. In addition to MQTT-based transports, Kaa now supports HTTP transport, either plain HTTP or HTTP with TLS. Unlike MQTT, HTTP binding is synchronous. It follows the request-response communication pattern and doesn't support the server message push. Let's go back to the Kaa Cloud and send some data over HTTP. Here is Postman collection with HTTP calls for all Kaa features. Here you can find endpoint metadata calls, data collection, binary data collection, command execution, etc. In this case, I will be using data collection feature, so I'll be sending data samples. I have already set application version for my endpoint and token. I'll be using Kaa Cloud account. We will send temperature with value 23, so let's execute this call. Also, let's change the value to something else and execute again. Data sample is successfully arrived and parsed into time series, and now you can view it on device telemetry chart widget. The new client credentials management in Kaa supports two types of authentication. Authentication using basic credentials like username, password, and using SSL TLS certificates based on X509 technology. Basic authentication is currently supported by all four MQTT-based types of transport in Kaa. X509 authentication is supported by the MQTT TLS transport. Here I will be using MQTT client for the demonstration client credential management Kaa feature. I have already prefilled it with Kaa Cloud host and port. Now I want to specify MQTT username and password. For that, you should go to the device management, credentials, enable basic authentication. Now it is successfully enabled, and generate basic credentials. These fields are optional, so let's skip them. Click create, and basic credentials were generated for us. Copy username, paste it, copy password, paste it, and click connect. It is successfully connected, and now we want to communicate with the platform. For example, we want to retrieve all available metadata keys over MQTT. For that, return back to the web dashboard, close the pop-up, go to the help, connectivity, enter a token. In my case, it is token 1. Choose application version, copy MQTT topic, paste it, specify random request ID, and send the request. We have retrieved all available metadata keys, which is level, description, mobile, and MAC. Now we want to connect our client over MQTT with TLS. For that, specify the right port, enable TLS, self-signed, and specify path to 3 files. The first one is just server certificate. I have already downloaded it and placed on my local machine, so I just select it. The second one and the third one are client certificate and client private key respectively. We can generate them on the web dashboard. So let's go to the web dashboard, device management, credentials, certificates, enable TLS in our tenant, add certificate, skip common name, TTL leave 1 year, and click create. So the pair were generated for us. Let's download them. Download certificate and download private key. Return back to the client and specify the path to these files. Certificate and private key. Click connect. It was successfully connected. And request metadata keys. Metadata keys were successfully retrieved. Now suppose you want to suspend your generated certificate. To do that, return back to the web dashboard, find your certificate, and suspend it. The client must be disconnected. Yes, it was immediately disconnected. Suppose you want to use the combination of MQTT over TLS with basic credentials. It is also possible with Kaa Cloud. Let's do that. Return back to web dashboard, activate this certificate again, go to basic credentials, enable it on MQTT with TLS transport level, turn on, generate basic credentials, let's skip it, copy username, copy password, and click connect. It was successfully connected. Let's request metadata keys. Everything is okay. Metadata keys were successfully retrieved. Kaa 1.2 supports the collection of binary data blobs such as still images, video segments, or audio recordings from your connected devices. There is also a new widget in Kaa UI that allows you to upload data from your devices to the platform, view the list of uploaded blobs, and download them to your computer. The uploaded data is stored on AWS S3 storage service. Let's go back to the demo. We will use Postman collection that we have already discussed, but this time we are interested in binary data collection folder. The first thing that Endpoint must do for uploading multimedia, it must obtain secret token using the new Kaa extension called BCX. BCX stands for the Binary Data Collection Extension. So let's obtain the token. I have already prefilled environment variables with endpoint token, with application version, and I will be using Kaa Cloud. Execute the call, copy token, and paste it into another call that will upload our file. We should paste it into header. Now we want to select the file that will be uploaded, name it another image, and execute call. Now we can view the uploaded file on the web dashboard. For that, go to the web dashboard, go to device page, scroll down, and here is our file, another image. We can download it and view it later. In previous Kaa version, endpoint configuration was a free-form JSON document. Now we introduce a verification mechanism for endpoint configuration by using configuration schemas. There is a new widget on Kaa Web dashboard that you can use to easily set up a configuration schema for your endpoint. Let's see how it works. As an admin, I have configured a widget that sends raw.json configuration to my endpoints. But I don't want my users or developers to broke my endpoints by sending invalid configuration that is not supported. Here is the problem. Developers or users can enter string, save it, and it will be pushed to my device. As a result, my device is broken, since it doesn't support string as a value of the threshold. But we can fix it. For that, as an admin, I go to Applications, search my application, and click on ECR. ECR stands for Endpoint Configuration Register Service that is responsible for managing device configuration. So click on it and let's configure it. Our configuration has only one field, which is threshold, and it must be number. So let's configure it. Choose number, make required, click Save, and return back to the configuration widget. Solutions, Development. Now we enter the number, save it, it was successfully saved. And now we want to try to save invalid configuration, gain foo. Now ECR refuses to accept the string as a value for the threshold key, since it must be number, but we try to save string. Kaa Data Collection Extension Service now supports enriching data samples with endpoint metadata attributes on the fly. In other words, you can feed the endpoint time series service and the pre-integrated analytics with data samples received from devices and enrich with their current attributes. This allows significantly reduce the volume of networking when you have a mix of frequently changing telemetry and less often changing attributes. For example, you may want to map environmental condition with weather stations at different elevations. The echolocation changes infrequently, so you can put the sensor elevation in the endpoint metadata. When you collect the actual weather conditions data, you no longer need to report the elevation all the time. It can now be sourced from metadata attributes and still available in your time series. To enable data sample enrichments with endpoint metadata, go to the Applications, your application, DCX, and click Enable. Also, you can specify a path by which metadata will be available in the resultant data sample on a PTS service. A PTS transforms raw telemetry into time series. Click Save. Now pretend that our weather station reports its elevation as a metadata. For that, open Postman collection, partial metadata update, specify elevation, and execute call. In our case, elevation is equal to 120. Return back to the web dashboard, device page, and verify that elevation was successfully reported. It was successfully reported, elevation 120. Let's configure elevation time series. For that, go to Application, find the application, PTS. I have already configured elevation time series, but pay attention to path. It is metadata, as we specify on DCX, and elevation. It is metadata key. Now the weather station starts sending telemetry. To simulate that, open the Postman collection, data collection folder, send data sample, specify temperature, execute call, update temperature, execute again, and now view the reported temperature time series with the elevation the temperature was reported on the device page. Go to the web dashboard, device page, and you can see that temperature 23 was reported on elevation 120, 24 was also reported an elevation with 120 value. Kaa 1.2 is now pre-integrated out of the box with the OpenDistro for Elasticsearch, a powerful open-source analytics platform. Each tenant's data is of course isolated and the security access policies are seamlessly integrated with Kaa. OpenDistro for Elasticsearch also provides a powerful Kibana interface for visualization. It allows you to customize your data charts, filter and query data, and quickly set up alerts based on your analytics. Our previous webinar was dedicated to the new analytics functionality, so feel free to watch it on our website for a complete walkthrough. I will touch on some base points today. In this demo, I would like to demonstrate you alerts functionality in OpenDistro in tandem with the Kaa platform. Click on the Alerts tab in the web dashboard and you will be redirected to the OpenDistro with all data from your devices. Here I have already configured monitors, destinations and triggers. Let's check monitor. It counts the number of data points where the temperature is higher than 30. And also it is scheduled to run every 1 minute. I have a trigger that is executed when the number of such data points with high temperature is above 0. And it is configured to send Slack notification in such cases. Also, I have a destination, which is Slack, but in your case, it can be something different. Let's simulate the scenario when Endpoint reports too high temperature. Now within 1 minute we should receive Slack notification. We were successfully notified. This is all we wanted to cover in today's webinar, and now it is time for me to answer your questions. Please give me a moment to look at those you already submitted, and please feel free to ask me more now.